Now that you've learned about the structure of atoms and how to find information about specific elements using the periodic table, it's time to learn how to draw the Bohr diagrams of elements by yourself. So before we start our first example, that being the metal magnesium, we need to talk about what each part of the Bohr diagram represents. In the center, we have the nucleus, which is the central part of the atom around which electrons are found. So inside of the nucleus, we need to identify what the element is, so we need to write what the chemical symbol of our element is, which in this case, because we're using magnesium, we're going to write the letters Mg here to designate that as the element we're writing. We know that the nucleus contains almost all of the atom's mass, meaning that inside the nucleus we will find magnesium's protons and magnesium's neutrons. So let's go ahead and find out how many protons and how many neutrons magnesium has. We know that the atomic number, that being 12 for magnesium, is equal to the number of protons and also equal to the number of electrons as long as magnesium does not have any charge. So if we know that there are 12 protons, we can go ahead and write the number 12, and we can write the letter P with a plus sign above to indicate that protons are positively charged. Now remember that the periodic table does not explicitly list the number of neutrons, so we need to do a slight calculation here. So we can see that magnesium's atomic mass is 24.31, so we can round this to the closest whole number, that being 24, and if we do some simple math, 24 minus 12 is 12, meaning that it has the same number of neutrons as it does protons. So we can write the number 12 here and then write an N next to it to specify that there are 12 neutrons here. Now, the most complicated part of writing a Bohr diagram for an element is how to deal with the electrons, because it depends on which shell the electrons are found in. For example, the innermost shell, the one closest to the nucleus, contains 2 paired electrons. So what that means is that because magnesium has 12 electrons, the first 2 electrons we are going to write in the innermost shell like this. And for reasons that you'll learn in future grades, electrons always exist in pairs like this. Now, when we're keeping track of the total number of electrons, it helps to keep a tally here. So there are 12 total electrons. We have used 2 in the innermost shell, so now we have 10 that we can use in the outer 2 shells. So if we go outward from the innermost shell to the second and third shells, each of these shells can hold a maximum of 8 electrons that exist in pairs. So let's go ahead and fill up the second shell with 8 electrons. So the way that we do this is we add electrons like this. So I like to think of these as directions. So 1 electron north, 1 electron east, 1 electron south, and 1 electron west. So once we have added individual electrons in each direction, then we can start pairing the electrons off. Electrons do not form pairs unless each direction has a single electron on it. So because there are 8, let's go ahead and add 5, 6, 7, and 8. So that means we've filled up the second shell with 8 electrons. So if we go back to our count, we had 10 electrons after the first shell, subtract 8. That means that we have 2 electrons left over that will have to go in the third shell. So let's go ahead and add 1 in north and 2 in east. So here, now we've added 2 electrons here, and 2 minus 2 is 0. So this means that we have added all of magnesium's electrons here. Now, you know that this is done correctly because if you look at the outer shell, that being the valence shell, the number of electrons that exist in the valence shell should tell you what the charge is, and we'll explain this when we talk about the next type of Bohr diagrams we can draw. So in summary about how to draw Bohr diagrams, start with the nucleus, write the element symbol in the center, followed by the number of protons, use the atomic mass and subtract the number of protons to find the number of neutrons, and then remembering that our number of electrons is equal to the number of protons, we can add 2 electrons in the first shell and then 8 electrons in every shell after that. Now, the second type of drawing that we're going to talk about are the drawings of ions. Now, ions form whenever an element loses electrons or whenever it gains electrons. And we know when an element is going to lose or gain electrons, or rather we know how many electrons an element is going to lose or gain, because this is going to cause their valence shell, the outermost shell, to become full. And remember that in the previous video and in the magnesium Bohr diagram here, you can see that whenever the valence shell is the second or third shell, 8 electrons means that it is full. So most of the time this means that we're going to have 8 electrons in the outer shell. So for example, if we take a look at aluminum, let's do the easy part. So chemical symbol Al, we see that there are 13 protons, and then if we do the quick calculation, 26.98, round up to the nearest whole number is 27, minus 13 means that there are 14 neutrons, so there is aluminum's nucleus finished. Now, because the number of protons is equal to the number of electrons, we can start adding electrons until we get to 13. So let's put 2 in the innermost shell. 13 minus 2 means we have 11 left over. Now let's go ahead and put 8 in the second shell. So 1, 2, 3, 4. Then we can start pairing them after we've added 1 electron in each direction. There's our 8. So 11 minus 8 means that we have 3 left over. So we can go 1, 2, 3, and that is aluminum's valence shell. Now remember that we're not drawing the Bohr diagram of aluminum as an element, we need to draw it as an ion. So here we need to decide whether aluminum is going to lose electrons or whether it's going to gain electrons. Well, we can see here that aluminum has a positive 3 charge. That means that we need to subtract a charge of negative 3, and this translates to losing 3 electrons. So we can see here, since aluminum has 3 valence electrons and 8 is full, we have a simple question. Which is easier, losing 3 electrons or gaining 5? Well, losing 3 should be easier because 3 is a smaller number than 5, so aluminum will have to do less work. So if we go ahead and cause aluminum to lose 3 of its electrons, let's remove the 3 electrons from the valence shell, and now we see that this valence shell here is empty, so the second shell becomes the new valence shell, and we can see that it is full. Now, because aluminum has a positive 3 charge, because it lost 3 electrons, so minus negative 3 is the same thing as positive 3, we can call aluminum a cation, meaning that it is a positively charged ion, which is simply an atom that has charge. Now let's take a look at oxygen. So oxygen, let's start with the easy part. So chemical symbol for O. It has 8 protons, as we see from the atomic number. And if we do 16 minus 8 to find the neutrons, that's 8 neutrons as well. It starts with 8 electrons, so let's put 2 in the valence shell here. So 8 minus 2 means that there are 6 electrons left. So let's go 1, 2, 3, 4, and the last 2, 5, 6. So here we can see, if we look at oxygen's valence shell here, the outermost shell, we see that oxygen has 6 valence electrons. Now remember, we need to get to 8 to make this shell full. Now, which is easier, gaining 2 electrons or losing 6 electrons? That's how oxygen can do it. Well, 2 is less than 6, so that is probably easier. So if we cause oxygen to gain 2 electrons, this is the same thing as adding a charge of -2, because each electron has a charge of -1, and when you add a negative number, you make it more negative. So if we put 1 electron there and 1 electron there, now we see that oxygen's valence shell is full because there are 8 valence electrons, giving oxygen its charge of -2. Now, oxygen is not a cation because it doesn't have a positive charge, so instead we call oxygen an anion, meaning that it is a negatively charged ion, meaning that it is an element that has gained electrons, giving it a negative charge. This concludes our video on drawing Bohr diagrams of elements and ions. To test your knowledge, take a look at the practice problems here. This one will test your knowledge to see if you can understand why different elements react more easily than others. But beyond that, you can test your knowledge of the structure of an atom, as well as try these practice problems drawing Bohr diagrams of the first 20 elements on the periodic table.